So to start out, what we're going to do is we're going to draw y equals x on here. Okay, parent function y equals x. So that's a linear function. Here we go. So there I have y equals x. And that is the line that our inverses are going to reflect across. That's how the x's and y's actually switch spots. Okay, because you switch your x and your y. So we're going to figure out the slope-intercept form and the point-slope form for this graphed line here. So what is your slope-intercept form? Okay, that is slope-intercept form. What is the equation of this line in slope-intercept form? Okay, so y equals negative 2/3 x plus 3. Okay, could you tell me your x-intercept? We got our y-intercept. My y-intercept's 0, 3. What's my x-intercept? 4.5. So 9/2, 0. Okay. So point slope, we need to know the point and we need to know the slope. So there's 3 points that this graph goes through that I know for sure. And I'm going to go ahead and use the point 3, 1 when I write the point slope form. Alright, point slope, you have y minus y1 equals m times x minus x1. Okay? Y minus y1 equals m times x minus x1. So, y minus y1. So, that one right there is y1. So, y minus 1 equals negative 2/3 x minus x1, which is 3. Okay? So that's my slope-intercept form and my point-slope form of that line there. Now the other thing I'm going to do is I'm going to make a table up here. So I'll have x and f of x. So I'm going to use the x values of those 3 points that I know. So I have negative 3, 0, and 3. And then with them I'll put their y values. So for negative 3 it's 5. For 0, it's 3. I kind of knew that from right here because it's your y-intercept. And 3 is 1. Okay? Now, that's good stuff there. Now we need to find the inverse. Okay? To find the inverse, we're going to switch our x's and our y's. Because that's what it says up there in that definition that you can get better definitions for later. Switch your x and y. So if I base it off my table, I would have f and that little 1 means inverse, because you remember earlier we were pushing second x inverse. There's your inverse. So instead of these being my y's, they're now going to become my x's. So 5, 3, 1. And then negative 3, 0, 3 are going to become my y's. Negative 3, 0, 3. So we're going to graph those points. So 5, negative 3, 3, 0, and 1, 3. Okay. So what is the slope of that line that I just graphed? What's the slope of that line? Negative 3/2. So I have y equals negative 3/2 x plus what? Four and a half. Okay, your x's and y's are switching spots. If this is x and this is y, and we switch them, this is now x and this is now y. So 9/2. So this x and y switch to give me my y-intercept, or x-intercept, sorry. This x and y switched for the y-intercept, and it gave me the x-intercept. So they did actually switch. So if I wanted to write it in point slope, okay, I can use, we'll just use the same one here. And now I have 1, 3. My x's and y's switched. So the inverse is, if I'm going to go point slope, I would have y minus 3 equals negative 3 halves times x minus 1. So talking about the vertical line test and the horizontal line test. If we're talking about the line that I drew the blue dots on, okay, would that pass the vertical line test? If I drew a vertical line through that line? Yeah, it would pass it. So that means it's a what? Means it is a function, okay? If I draw a horizontal line through it, would it pass that test? The blue one wouldn't, this one wouldn't pass it? Well, so if it passes that one, then the inverse is a function. Okay? So this one over here, drawing a vertical line, it passed the vertical line test. Drawing a horizontal line, it passed the horizontal line test. So that means it is a function, and its inverse is a function. Which means, if you look up here, it's 1 to 1. What, Camber? It is 1 to 1. Okay? Who's confused? Nobody's confused? I don't believe that. Alright then, number 7. So, what line does the inverse reflect across? Huh? What line does the inverse reflect across? I wrote it down. Y equals x. Okay? That's the first thing you got to know. Your inverses reflect across y equals x. So, what is your slope-intercept form? Yeah. I have y equals negative 5x minus 1. Okay? It's going through right there. It's going through right there. And the other one won't fit on there. So if I wanted to put it in point slope, we could use the y-intercept here, or I could use that point up there. I'll go ahead and use the y-intercept. So we're at 0, negative 1. So I'm going to get y plus 1 equals negative 5 times x minus 0. So there's your slope, intercept, and your point slope. What's the next thing I did? Made a table. Okay, so we're only going to have 2 numbers now. So x and f of x, that's my original function. So I have negative 1 and 0, 4 and negative 1. So that is my original. Then we have our inverse. Okay, so switch your x and your y. So x's and y's switch. 4, negative 1, negative 1, 0. So we're going to graph those points. So 4, negative 1, negative 1, 0. See if I can draw a better line than I did last period. It's a little exciting last period. I'm not too shabby. Okay, so can you tell me the, well, let's do this. All right, we'll see what happens. Can you tell me the slope-intercept form for this line? You should be able to tell me the slope like that. Negative 1/5 x. What is your y-intercept? Okay? Let's go back up here then. Can you find your x-intercept? That's your y-intercept. I need the x. Negative 1/5. Move your 1 over. Divide by negative 5, which is negative 0.2. So I'm at negative 1/5, 0. It's your x-intercept. Your y-intercept was 0, negative 1. Okay. So if this was my x-intercept, it's now the y-intercept. So minus 1/5. Here's your x-intercept. It's at negative 1, 0. So they are switching spots. Your x and y's are switching spots. What do you think that's going to mean for the domain and range when we start doing that? They're going to switch. They're going to switch. Alright, so if I do point slope, I use 0, negative 1, so we'll use negative 1, 0. I have y minus 0 equals negative 1/5 times x plus 1. Ready? Questions? This right here, point slope. I plugged negative 1, 0 in, and it's x minus x1. So you have x minus minus 1. Yep. Okay. Anybody else? Because when you reflect the inverse, it's reflecting across y equals x. Okay, so if you have a quadratic, it's like this, right? And it's going to pass the vertical line test. Okay? If I draw a horizontal line, is it going to pass that one? No, right? Okay, so when I reflect something across y equals x, it goes like this. Okay? Is this a function? Why not? Touches it twice. So basically the horizontal line test is telling me if the inverse is a function before I have to reflect it. Next. Or did I answer it okay? Yeah? Good. Alright.